Okay, we are live. So good morning, everybody, or should I say good afternoon, as it's just turned 12. I'll be doing a talk today on a high-level overview of managing Linux servers. The aim isn't to go into depth on any particular topic. I'm going to be looking at just some high-level topics just to get you an idea of how we manage Linux servers and some of the tools and some of the methodologies we use when managing Linux servers. My name's William Oldham. I'm a second-year computer science student at the University of Lincoln. I'm also, on the side, a system administrator, so I work a lot with Windows servers and Linux servers on the side. And so that's sort of the experience I'm going to be drawing from in this talk. One of the first things I'm going to talk about is infrastructure automation. And this is one of the big topics that's been around at the moment. It's a topic that's very prevalent in the rise of cloud technologies, because with cloud technologies, you need a way to automate the provisioning of any cloud resources that you have. So let's take a moment here just to imagine the problem it comes when managing a certain amount of infrastructure. So you are a system administrator for a company. You may work in a team, or it may just be yourself. You are managing a certain amount of servers. And initially, you might start off managing just one server. And that one server is fine to manage. You just run the commands to configure it, and that will be fine. However, when you start to get more servers and even more servers, then it becomes quite a big problem to manage. Now, obviously, I've kind of exaggerated here with maybe the amount of servers that you might manage, especially by yourself. You would probably be working in a team if you had this many servers to manage, but you get the idea. Once you have to run the same configuration on a numerous amount of different servers, usually it can be the same amount of same configuration for those servers. So they may be servers that run a file server, and you have to have those servers be highly available. So you need multiple servers to send requests to. So what you need is a way to set up all these servers with the exact same configuration, the exact same networking, and all of the policies and updates on top of that to make sure that the infrastructure is also secure. So the solution that we have to that is automation. And this is where, as an administrator, you write a script, or you use a program to write a script, and then you push that script out to all of your servers. And then this is scalable because basically you are writing a configuration that says, hey, configure this server in a particular way. And then you are going to all these servers saying, hey, here are the instructions. I want you to configure yourself using these instructions. And then the servers will go ahead and do that. And what this means is that you can roll out a massive amount of infrastructure using just a few simple configuration files. And it makes your life a lot easier because you also know that each one of those servers is exactly identical in terms of configuration. And if they're not, then the tools that you are using to provision these technologies will tell you that they are not compliant and they are not within the scope of that configuration file. And so I'm just going to look at a few sort of automation frameworks which you might use to achieve this task. And on the left-hand side here, we have the first-party cloud tools. Now, these are the cloud tools that are provided by a cloud provider to manage their own system resources. So I've just picked the three most popular cloud platforms there. We've got Azure, AWS, and Google Cloud Platform. And they each have their own respective tool to provision resources on their servers. So these are typically done through a template. So you configure a server, and then you tell that resource manager to take that server and put it into a template. And then that template can be scaled up to as many servers as you want using these configuration tools. And it makes it very easy to create a server. So you have a server that serves web requests, and you make a template of this, and then you say to Azure, for example, hey, I want 500 instances of this web server, and they all need to be connected by load balancers and things like that. And Azure will just go and do it for you. And there is very little manual labor required. Obviously, you have to go and learn about all these tools and learn how to configure them properly, which can take quite some time. But once you've got that under grasp, it can be a massive, massive time saver. On the right-hand side here, we've got some third-party tools. The first one of which being Terraform. Now, Terraform is what I'm going to call the Swiss Army knife of automation. And that's because it works with lots of different cloud providers to actually provision resources. So while the Azure Resource Manager, AWS CloudFormation, and Google Cloud Deployment Manager only work for their own individual platforms, something like Terraform has numerous amount of plugins to actually plug into all of these cloud providers and provision resources. What this means is that you don't have to spend time researching each individual tool for each of the different cloud platforms. You just write a configuration file for each of them that looks relatively the same. Obviously, there will be some differences between cloud platforms, but what you're looking for is that all of the configuration is done centrally with one tool. And you don't have to, or your team doesn't have to go to multiple different tools to configure one resource, configure another resource. This is especially handy if you've got your resources spread across multiple cloud platforms. Say if you wanted, for some reason, to have your website distributed across multiple cloud platforms so that it's not on just one cloud platform. You're not just reliant on Amazon. You're not just reliant on Microsoft. You could split them across Microsoft Azure and on AWS or something like that. And then what you can do with Terraform, you just configure the services using the same tool. And so Terraform can be a really, really handy tool to actually work with lots of different cloud providers using the same configuration files within its own platform. So Terraform is the only one on this third-party tool that's really primarily designed to work with cloud platforms. All of the others can work with cloud platforms just fine, but Terraform is the one that is especially keyed up towards working with cloud platforms. The next one we have on the list here is Ansible. Ansible it's actually quite a nice tool to use for smaller deployments because it uses what's called a push model of automation. So what this means is that instead of the clients, shall I say, asking the server what configuration it wants, the server is actually pushing that configuration out to the clients. The advantage of this is that you don't actually need any special software installed on those servers. All you need to the servers is an SSH connection. So in that SSH connection, you would just use your SSH keys, your public and private keys, to connect to the server automatically without a password. And then Ansible will be able to run commands on those servers to configure them. So that's a really nice way of configuring servers that you don't necessarily have the time or effort to go through and install multiple different agents on. Now, the two on the right-hand side is we've got Chef and Puppet, and these do the opposite of what I just described. These use a pull model of automation. And what this means is that they have an agent installed on them, a piece of client software, that basically goes and asks the server what configuration they should have. What are my policies that I should have? What are my updates? And then once they have that configuration, they will go ahead and do it. And the big advantage of this is that it's a lot more scalable, because instead of the server pushing out the configuration, usually all at the same time to all of the servers, what you're doing is you're having the clients that will each on their own schedule ask the server for the configuration periodically. And that means that these methods of automation are actually a lot more scalable, up to sort of thousands and thousands and thousands of servers, because they are not being done all at the same time. There is a slight difference between all of the different timings of them, which means that you don't have such a high demand on the server, which you would have if you're trying to push everything out all at once. Because when you push everything out using Ansible, I'll just go back to that, you have to establish an SSH connection to each one of those servers. So while SSH connections aren't terribly intensive, that is a lot of connections to have. And so this is where something like Chef or Puppet comes into its own, because they establish their own connections to the servers one at a time, download the configuration, and then get off the server, and then the server is free to service other clients. Now, all of these tools fall under the umbrella term of infrastructure as code. And what this means is that you can programmatically or somewhat programmatically create infrastructure. And this is the really key thing that's coming into its own with cloud platforms, is that you want to be able to centrally manage and all of your configuration files for the cloud platforms, or even just local servers. And what this means is that any of these files, so Ansible uses playbooks, Chef uses recipes, and Puppet uses something called manifests. Those are each of the respective configuration files. And you can store those in a central repository. So you could store all the configuration files on GitHub, for example. And then those configuration files can be version controlled, and they can be edited using pull requests, shared with a team, and things like that. So they are very desirable for using as configuration tools, because they work very well in team environments and in environments where there are a lot of servers. So that's the sort of overview of automation frameworks. I didn't want to dive in too much into that because there is a lot you could talk about with them. So I'm going to move on to scripting. Now, scripting sort of comes hand in hand with automation, but I'm going to focus more on just scripting in general. And scripting is a very common thing that if you've ever used a Linux server, you probably would have used a script at some point. And using that script allows you to run multiple commands in a sequence to achieve some sort of goal. So why would we do this? So for the one part, it saves a lot of time. So running a script is a lot quicker than entering 10 commands one after each other, because the 10 commands, you have to wait until each of them are finished, whereas the script, it only requires your interaction, or theoretically only requires your interaction for that first command, providing that you've written your script in a way that it doesn't require any more interaction. So it saves time because you only have to run the one command at the top, and then it just goes through and does all those 10 things without requiring any input from you. And because it doesn't require any input from you, it also reduces the likelihood of human error. So if you've got a script that needs to configure a critical part of your configuration on an infrastructure, for example, you don't want to make mistakes with those configurations. You don't want to make a typing error, or you don't want to miss a command out or anything like that. This is where a script comes in really nicely. And I've put an asterisk on that because it says, providing the script was written correctly. Scripts are only as smart as the person who wrote it. So if the person who wrote a script in a really, really bad way, and it was just as good as running it by yourself, and it wasn't really any more fault tolerant, then it's not going to save you from that. But what a script will do is that it will run the same thing every time, no matter what. It's very deterministic. It won't have variable output, and it won't forget commands, or it won't mistype something or anything like that. And because of this, it's also useful for processes that need to be repeated or done in a certain order. So because they need to be repeated, you don't necessarily have to want to go through 10 commands each time you need to do a process, especially if the process is every minute. So this would be done for more automated tools, for cron jobs, for example. Cron is the scheduling engine within Linux that allows you to run repeated tasks. Or in a certain order, if the commands need to be run in a certain order, for sure, it means that the script will run it in that certain order every single time. It's not going to forget about which way two certain commands come. And the last two sort of points, it encapsulates the commands. So if you have a process that only accepts input to run one command, so you have, for example, Git, you can run what's called a hook. So before you commit something, you can run a script. What you can put in there is, instead of just running a command in that hook, Instead, you run a script, and that script can do lots of different things. So that's what it can be useful for. It can be useful for basically turning 10 commands into one command. And it acts as part of the documentation as well. So because it is exactly describing what it's going to do by the fact that it is the exact commands that's going to run, it can be used almost as part of a documentation, providing that you've got some commenting in there to show the process and how it happens. So you don't necessarily have to rely always on documentation that might be out of date, for example. One of the good things to do with scripting is to run what I like to call a pre-flight checklist. And this is to make sure that as much validation as possible is done at the start of the scripts before you actually run anything. And this is to check things sort of, you've got the correct dependencies installed, you've got correct file permissions to do what you need to do, you're running with the correct user account. So for example, your program might need to run as root, or it might need to run as a special service account, or even to check that you've got internet connectivity. And so if you check all of these things at the start of your script, what it means is that there is a smaller likelihood that you're going to leave the computer in an undesirable state, a partially modified state, which might require more work from you to actually figure out at what point it stopped and how to repair that process, because you might need to necessarily go back and start again and run the whole thing again for it to work properly. So doing as much validation up front, so checking your dependencies, so making sure you've got correct commands installed to run what you need to run, and then making sure that you've actually got access to write to the stuff you need to write to, it means that there's less of a likelihood that you're going to leave anything in a partially modified state. Okay, I'm going to talk a little bit about something called idempotent as well. Now, idempotent basically means that if you run a script multiple times, it runs the same as if you've just run it once. And so what that means is, for example, if you're creating a directory, which I've given an example there, if you're creating a directory, once it's created, you don't want to try and recreate the directory because you know it exists, because that would most likely create an error if you tried to recreate a directory. So what you want to do instead is check if the directory exists, and then if it doesn't exist, then you should create it. And it just creates more reliable scripts so that if you run a script twice, it's not going to error out and it's not going to cause damage to your system or anything like that by leaving things partially modified or overwriting things that shouldn't be overwritten. Because if you've got a script that creates a file, you write some important data to a file and then you accidentally run the script again, it might, if it's not idempotent, it might just rewrite that file, might wipe it completely, and then you've lost anything important that you might have put in that file. So idempotency is quite an important thing within a script, because you will often run things more than once accidentally. And well, I'll just say there that the link at the bottom, that's some examples of some idempotency. So there's some good examples that you can use within scripting. So that's like creating a directory, copying files, things like that. It's just a good little example of some things to look at there. The logging. So logging is something that a lot of scripts lack in, and it's something that needs to be done a bit more to actually inform the user about what's happening. So I've got sort of 4 rules about scripting that scripting should really be done with. One is they should be descriptive. It should actually tell you what's happening, and preferably tell you what's changed as well. They should be useful. So don't just print logs for the sake of it. They need to have a use. They need to describe what's going on. Don't print something for the sake of it. Don't just print hello world in the middle of a program. Print something that actually means something to the user. They should be concise. So you don't want lines, a single line that spans multiple lines on your screen, because you don't have a very wide screen most of the time. So what you want to do is create your logs as concise as possible, have all the information that you need, but don't have massive long lines of text, because that can make it really hard to read when you're actually looking through log files, especially if you've got a lot of logs to go through. And consistency. This one doesn't always apply, because this is more for scripts that are going to be run by other programs and read by other programs. So a consistent format for the log files can help, because it'll be easier for you to read because you can look down columns. So if you have everything that's in a specific column, so you've got tabs between everything so they all line up, it can make it really easy to look down and actually read things. And also it might be helpful for programs that actually need to parse a log file. For whatever reason, they might want to get the time of the log file or anything like that. And just as a bonus point down there, if you've got a program that's running for a long time, it's actually good to try and log as many times as you can within that long process to tell the user that it's actually still going. I haven't just frozen, and it means that there's less of a likelihood of killing the program. I have been a bad person to do that before. You sat there running a script and it's taken too long, I'm just going to cancel it, when actually there was only like a couple of minutes left. So that's where progress bars come in as well. If you can get a progress bar in a console application, which is a bit more difficult, but it can be done, that can be really good to show users about the progress of an application. So enough talking, let me show an example of a good/bad script. Now, this is a very simple example. It's quite a trivial example, but what I've got here is I'm echoing a line. So this is just a line of text, and I'm putting this in a file called fstab. Now, fstab manages the mount points of the system. You can mount devices using fstab. And all this command is doing is it's echoing that string there into that file. It's appending it to the end of that file, which is what the t-a command is doing there. The sudo is needed because you need to elevate your privilege to a root level, because fstab is a root protected file. You cannot just edit that as an individual user. There's nothing inherently wrong with this single command, but it doesn't do any of the things that we spoke about. So it doesn't do any logging, it doesn't do any pre-fight checklist, and it isn't idempotent, because if you were to run this multiple times, the same line would get added to the bottom of the file multiple times. So what I've got written here is a slightly better example. So we have at the top there the pre-flight checklist. So this is checking whether the user we're currently running at is root. So the EUID is the current user's logged in user ID. And then it's checking if that's not 0, because the root user is 0. So you need to check if that user's ID is not 0, it must not be root. So we're going to exit this program. And we're going to exit with 1, which is a error code. So the exit codes, if you exit with 0, that's success. If you exit with anything other than 0, that's a failure. So I'm just exiting 1 here for simplicity. On line 7, or should I say line 8, we're declaring a variable that's going to take that line we're inserting into the file. And then on line 9, in that if statement, we're going to use a command called grep, which is just going to check for the existence of that line within fstab. So what that if statement is saying is, if this file doesn't exist within fstab already, then we're going to go ahead and write it into the file. Otherwise, we're just going to skip, and we're going to inform the user that we've skipped. Which are those 2 logging there we've got as well. So we've got the written, the SDA1 mount point, which is saying, well, I've completed the operation. And the bottom one, which is saying, well, it already exists, I don't need to do this again, I'm just going to skip. So you're telling the user exactly what you've done. And on line 11 there, where we're just piping the output of t to dev null. And the reason for this is because t actually outputs the line that it inserts into the file. And so we don't want that just appearing randomly in our output. So I'm just going to pipe that to dev null just to avoid any confusion. Okay, so that's an example of what might be a good script to write. In the example of this would be a good script, because this is also can be run completely automated, doesn't need to be doesn't need to have any user interaction whatsoever. So this can be run by other programs as well, which makes it nice and useful. Okay, so that's scripting. Now I'm going to cover some different security topics on this as well. So the first topic that I'm going to talk about is Linux file permissions. And so this is something that I find a lot of people don't actually quite understand. They know some of the numbers and they know sort of how it works, but they don't know why. So in Linux file permissions, a permission on a file or a folder is made up of 3 numbers. So I've got an owner, a group, and other. So it's actually a bit misleading. I should have named the green X owner. Should have named it user, because the user and the group are actually both the owner of the file. A file in Linux is owned by both a group, a user, and a group. What you usually find is that the group is the same as the user. So as you can see at the bottom of the slide there, the output of the command ls, so that's the list command, you can see that all of those files have an owner user of root and an owner group of root. So they are both owned by the root user and group. When you create a user as well, they also get a group created with them. It's not an explicit group. You'll not find it in the listings of the group, but it exists when you create a user. So each user has the same name group assigned to it. And then on the left-hand side there, you've got the permissions. So it's probably a bit far out for you to read that, but what you've got there is rwx, r-x, r-x. And what that's saying is that the user, which is the first 3 bits, and I'll cover this in a minute, have read, write, and execute permissions. And then the group and other only have read and execute permissions. So I'll talk about where those numbers come from. So each of the numbers ranges between 0 and 7. 0 being no permission whatsoever, and 7 being full permission. And how these numbers are made up is they are formed from 3 bits. And each of the bits represents a read, write, or an execute operation, as you can see there. So read is 4, write is 2, 1 is execute. And these numbers can be added together to create the different levels of permissions that you want to give to a file. So for example, there you've got 0, which is no permission, so that's nothing added together. You've got 1 and 4, which is execute and read, gets you 5. You've got write and read, which is 6. And then you've got full permissions, which is execute, write, and read, which gives you 7. So that's where the numbers come from there. So these are some example permissions. So here you've got 777 on the left, which is probably one of the most dangerous permissions you can assign to your system. I see a lot of people, if something doesn't work, they assign 777 to it and just roll with that, which will work, but it's not very secure at all, because it means everybody can access this and there is no restriction on it whatsoever. Next, you've got 700, which grants full permission to the owner user of the file, but no permission to the groups or anybody else. And then, as you can see along, you get various different permissions there. So you've got 755, which is full permissions for the user, only read and execute for the group and other. So you can combine these numbers as much as you want. Usually what you have is the number at the start. So the user number is usually the highest number. And then you either stay the same for the numbers, so in 777, or each number decreases as you go down. So you could have the permission 750, which is full permission for the user, read and execute for the group, and anybody else doesn't have access to the file. So you can create these different levels of permissions on the files, and it just makes the file permissions, it's just how to understand them. So to actually change those permissions, use the chmod command, which I haven't shown on here, but you do chmod, then the three numbers, and then the file name. So if I get time at the end, I'll show that in a demo of how to change the ownership of a file and how to change the permissions of a file as well. So next thing in terms of security, which I sort of alluded to a little bit in the last one, is the principle of least privilege. And this is the idea that you don't want to give everyone on your system access to everything. It can be a very bad thing to do that. And from this, we have one conclusion, and that is the root user is dangerous. I probably should have put very dangerous in there. Root user is the true super user of the Linux operating system. It can do everything, it can overwrite everything, it can delete everything, which is bad, suffice to say. The bad thing about it as well is that it can override all file permissions. So if you were to assign a file permission of 000 to a file, root would still be able to access it. So even though you think you've assigned no permissions, so nobody should be able to access this file, root can still access it. And there's a few things that come out of this. First, if you were to accidentally run a malicious process, or intentionally run a malicious process, a lot of damage can be caused to the system because the process will have access to everything. It's also very easy to delete something that you shouldn't delete. And this has been a joke that goes around on the internet quite a lot, and it's the remove minus, it's like the recursive remove of the root operating system. So if you do a recursive remove @ on Linux, if you're running as root, it will delete everything with no mercy. It won't prompt you, it won't ask you, it will just go ahead and delete everything, which, suffice to say, is very bad. I've done it before, by the way. Don't recommend it, because what I ended up doing was accidentally wiping my boot partition of my dual booted computer, and my Windows installation couldn't boot either. So even if you think you know what you're doing, chances are you don't know what you're doing. When a program is run as root, if that program were to ever be compromised as well, they have full access to your server. So on the similar vein of a malicious process, if you have a completely benign process that you run, say a web server, but that web server was to somehow get compromised, then that person who has infiltrated that program has full access to your server, which is not good. So what should we do instead? Well, we should create multiple accounts for all of the different levels of permission. So as you will be usually given a root account for a server or for a virtual server that you might order. You are usually given root by default. The first thing that you should do is create a separate account for yourself. This is done by default on Ubuntu server, I know that much. And you create a separate user for yourself. And then what you have to do is use sudo. And you use sudo, which is short for super user do. And basically it grants root level access on demand. So when you want root level access, you run sudo followed by the command, and it does it. Sudo also provides the extra safety of the fact that it actually times out. So once you've run sudo once, it has a certain amount of time where you don't need to keep re-entering your password. But after a certain amount of time, it will time out and you will need to re-enter your password. And this means that if anybody gains access to your computer and you're still logged into an SSH session, for example, you don't necessarily have a compromised server. You might just have to get some files back that somebody might have deleted or something like this. And on the vein of services and programs, you should be creating service accounts for them. Now, service accounts are basically a user account that cannot log in, and the application just runs with as low privileges as possible, and you grant that user access to the files it needs on that computer so that it can access anything it needs to write to, anything it needs to read to. And this means that you've got a very locked down way to actually control what services and programs access, because you can create an individual account. So an example of this is if you run an Apache HTTP server on an account, it creates an account. It used to, I don't know whether this is still the case, it creates an account name called www-data. And any file that has that permission on it, so grants permission to www-data, means that the Apache web server will be able to access it. So that's how you lock down your system in terms of user accounts. There is also another way to lock down your server, and that's using firewalls. So firewalls, as I'm sure many of you will know, lock down network connections. So I've got a lovely little diagram here. So imagine you've got your network interfaces here. And for the sake of simplicity, I've just got Ethernet 01 and Ethernet 02. So those are two separate interfaces. I've just repeated Ethernet 02 twice just for demonstration. And what you can do, so on that green box there, it says allow Ethernet 02. So this is at the very lowest level of the networking stack, so known as the OSI layer 1/2 for all the networking nerds that might be here. You can allow only packets to come through a specific interface. You can block everything else from coming in to a different interface. So this packet is going to try and come in, and the rule is going to evaluate whether the interface it's coming in on is the right interface. Obviously, this rule only allows Ethernet 02. This is Ethernet 01, so we're going to deny that request. On a similar vein, you can take a step up into the networking stack, and you can have IP addresses. So this is layer 3, so this is the networking layer. And this rule here is we're saying block any source IP address, so the IP address where the packet originated from, block a source IP address of 8.8.8.8. And as you can see here in this packet, it does have a source IP address of 8.8.8.8, which means coincidentally it is from the Google's DNS server, because that's Google's DNS server's IP address. And because of this firewall rule that we've got on 8.8.8, it blocks that packet too. And then as a final layer, what you can do, which is usually as far as Linux firewalls go up to, is you can block specific ports. You can block or allow specific ports. So now this rule at the bottom here is saying, well, I can allow only port 25, the destination port 25. So again, I'm going to look at my networking packet. I'm going to look at the port and say, is this port 25? No, it isn't. So I'm going to block this request. And all of these different rules can be layered up to block specific IP ranges, block specific port ranges, allow specific port ranges. So they can all be layered up and combined with each other to create very powerful filtering rules. The filtering stack on Linux, not something you'll usually need to know about, but I'm just going to cover it very quickly anyway for anybody that might be interested. At the kernel level, you have a module called netfilter. And this is the module that is responsible for taking in all of the net requests and filtering it and telling it what to do. Do we want to actually process it in the computer? Do we want to forward it? Things like this. And that sits at the very base level. And then we've got IP tables and NF tables. And these are the low-level ways of controlling netfilter. So these are the low-level ways of controlling what the kernel actually does with these packets. So these are the first place where you can define the rules I showed on the previous slide. So you can define IP addresses to allow, protocols to allow, ports to allow, specific interfaces. And you don't have to just do allow or block. You can also do rules that forward requests or change requests. You can do network address translation, which is where you translate a specific network address into a different network address. This can be used for you can create a router in Linux, for example, and this is how you would do that. And then on top of these layers sits two sort of more user-friendly ways of controlling the firewall. So one is UFW, which stands for uncomplicated firewall. And then you've got Firewall D, which is just another way of controlling it. It's a separate program. And so I'm just going to quickly look at UFW and to show you how simple it really is to actually configure. So here I've got the basic usage of UFW. So here I'm allowing SSH, I'm allowing HTTP, and I'm allowing HTTPS, and then I'm enabling the firewall. And this is the default simplest thing you can do to set up a firewall. And this is what you should be doing whenever you set up a server. First thing you should be doing, or one of the first things you should be doing, is setting up a firewall. And what this firewall allows, it has to be run as sudo because it's working at the root level. So as we talked about with the least privilege, I don't have on my own user the privilege to edit the firewall rules. So I need to elevate myself temporarily to the root level. I need to edit the firewall rules, and then I will come back down to my own user level. So here I'm allowing the protocols SSH, which is port 22, HTTP, which is the port 80, and HTTPS, which is 443. And these are pretty standard ports that you would allow access to. And then at the bottom, I'm enabling the firewall. Something you should be careful of is to, if you are connected by SSH and you don't allow SSH, as soon as you allow the firewall, your SSH connection will be cut off. I've been caught out by that a couple of times. You forget to enable SSH, you enable the firewall, and then whoopsie-daisy, you're locked out of your system. So that's something to make sure to keep in mind. You allow and deny specific IP addresses using UFW, bit out of the scope of showing you how to do it here, but there's a full guide there, and there's also the man page, the manual page, in those two links there. And you can also specify the rules for different network interfaces like we talk about. So I'll do a quick demo of setting up something like UFW. So what I've got here is I have got a Linux server. This is a Ubuntu Linux server. I don't think I can actually zoom this in. Let's see. Oh, I can. So I've zoomed that in a bit. So that should be visible. And so what I've got here is I've got one good app, and then I've got one bad app in here as well. So we've got bad app in here. And if you've got any questions about this, just pop it in the chat and I will answer as I'm going along. But I'll just continue showing you this. And what I've got here is you can request. So this is a bad process. So what we're going to pretend is that this process shouldn't be allowed to access out to the internet. This is a process that's just popped up on our system, and it's hosting a port that's trying to get to the outside world. And here is the legitimate process running on port 80 that just outputs good process here like that. And then this is the bad process. And so what I'm going to do is if I come into Linux here and I do sudo UFW allow, and then I'm going to do SSH, which is what we were talking about before. And then this is the privilege escalation. So here I'm being asked for my password to authenticate for myself. If I don't do this, and I try and just skip the password prompt, 3 incorrect password attempts, it's not going to run the command and it's just going to kick me out of it. So if I enter my password, you can see there that it says rules updated. And I'm also going to allow port 80. So I'm going to do 80/TCP, so TCP port 80, or you can just do HTTP here, and also rules updated. So then I will do sudo UFW enable. The firewall is active, and I can check this by doing sudo UFW status. And you can see there we've got the 3 rules in. So we've got 22 TCP, 80 TCP, and then the IP version 6 variants of those as well. And what I can do is if I come over here to my window, I refresh this, I can still access the good process, But if I refresh this window, it's taking a lot longer, and this should eventually time out, which it looks like it's going to. This will not be accessible anymore. It's taken a little while to time out because it's just a bit slow, but suffice to say, it's definitely not being allowed access anymore. Yep, there we go, site can't be reached. So I should mention as well that the default firewall rules, they allow any outgoing connections by default. So any connections that you're making, you don't have to allow them through the firewall. You just enable the firewall for the incoming connections. So if you were on a system, your own personal system, and you only wanted to allow SSH in, so what I can do is I can remove the AT/TCP. Apparently I forgot the syntax of how to do that. It's delete. So if I just clear, I spelled remove wrong anyway, so delete. Doesn't like me, but you get the idea. So basically, you can delete that and only allow SSH in, so if you wanted to connect remotely, or you could not even allow SSH. So what I could do is I could do UFW reset. I need to be root. So I'm just going to escalate myself again, reset it to default. And then if I go to the status, we should be able to, so you can see there that the bad process has popped back up. But if I enable the firewall again, actually nothing will be able to get through now. So not even port 80. So that's a very quick demo of firewalls, essentially. That's it for me. It's been sort of a whistle-stop tour of everything Linux. I hope it's been informative, and I hope that you've got something out of this. If you've got any questions, you can reach me at any of those links there. The slides are also available at the link at the bottom there, lincoln.ac/Linux slides. If you've got any questions, feel free to contact me. But other than that, thank you very much for coming, everybody. I hope you have a lovely Christmas and a happy New Year, and enjoy the rest of your day. Thank you very much. See you later.